Hi, this is Dr. Emenacker. In this particular video, we are going to look at three linear equation story problems with their solutions. These problems very closely pattern your homework problems, but I've written them up so that while they are closely patterning your problems that you have in the homework, they're different enough that it'll still allow you to be able to go after your own solutions for the homework problems while using the patterns provided by the solutions to these three problems. Let's take a look at the first one. It says that heavier vehicles cause more wear and tear to roads. I mean, that's just a fact. A semi truck causes more wear and tear to a road than a lightweight car. Licensing fees and tolls and things of that nature are all based on the amount of wear and tear the vehicle is going to cause to that section of roadway. So let's take a look at what's going on here. It says the state charges bridge tolls based on the vehicle's curb weight. A gas-powered version of a car weighs 3,245 pounds. This is a fairly common weight for something like a Toyota, a Honda, a Mazda, a Ford, things of that nature. By removing the gas tank and the weight of that gasoline, then adding the battery for a battery-powered version of the exact same car, this new car, the modified car, weighs 4,090 pounds. It really is true that the battery in EV cars weighs about 1,000 pounds, which is pretty incredible because that means that on something like what I just mentioned, Toyota, Honda, Ford, small sedan, the battery is going to be a third of the entire weight of the car. Okay, so let's take a look at what's going on as far as the questions here. If the toll is $3.50 for the gas-powered car, what will the toll be for the electric-powered version of the car? In this particular problem, we'll just go ahead and assume that it's a somewhat linear relationship between weight and tolls. Um, while the actual wear and tear is not linearly related to the weight of the vehicle, it's actually a more complicated equation. We'll just go ahead and assume it's linear to keep things straightforward here. Okay, so for part A, we're provided the information that a car with a weight of 3,245 pounds incurs a toll of $3.50. Now, the first step in this process is we need to figure out what is X and what is Y. X is the independent variable. Okay, that's something you get to pick. And then the toll, or the dependent variable is a result of what was picked. Well, when you pull up to a bridge to pay a toll, it's the vehicle weight that determines the toll. The toll is dependent on the vehicle weight. It's not that the weight depends on what they charge you. What they charge you depends on the weight. So our X variable is going to be the weight. The dependent variable, the toll, is going to be the Y value. We're assuming that it's linear in this case as far as the toll being charged. So what we can do is we can set up here an equation where we're just going to do a ratio. So for example, a toll of 350 is related to a 3,245 pound car, like a toll that we don't know is related to a 4,090 pound car. So what we want to do here is solve for t. Since we have a fraction equal to a fraction, okay, we can cross multiply. So what we're going to have is this 3.5 times the 4090 is equal to 3,245t. Okay, if we take the 3.5 times the 4090 and then divide it by the 3,245, looks like the toll here is going to be, we'll round it off to $4.40. It's actually $4.41, but I can't imagine them getting bent out of shape over a penny at the toll booth. It's just going to create a hassle as far as tolls and managing the money. Actually, what the state would probably do is run this toll up to 450. Okay, but the question to part A is, what will the toll be on the electric powered version of the car? The toll is going to be about $4 and the actual mathematical amount, $4.41. What would really happen in the real world, either 440 or 450. Part B then asks you to determine a linear equation to compute the toll based on curb weight. Well, we actually have 2 points now. We have the point 3245, the x value, and its corresponding value of 350 for y, and we have a point of 4090 for the weight, and a corresponding toll of 441. To get the equation of the line, what we need to do here is to compute the slope. The slope is the change in y over the change in x. Doesn't matter which of the points we plug in first, just make sure that the y values go on the top with the corresponding x value in the denominator. I'm going to do the 350 here and the 3245 here. So this is going to work out to be the 441 minus the 350, or we're going to wind up with 0.91 in the numerator, over we have the 4090 minus the 3245, which is going to give us 845 in the denominator. So this works out to be the 0.91 divided by the 845 is going to be 0.001. There are some other digits beyond that, but we're not going to worry much about that. So our slope in this case is 0.001. Okay, now there are several ways to get an equation for a line at this point. The way that I typically work this is probably not what you learned in high school or middle school, wherever you were first presented this information, but it's fast and it works, and mathematically it's correct. Realistically, when you get in the real world, what they want out of you business-wise is fast, accurate, friendly with your customers, and on time. If you can do those 4 things, you're going to be a success in business. Okay, so what I'm really after here is I ultimately want to wind up with the equation y equals mx plus b. At this point, I know the value of the slope. It's right there. Okay, so I can write part of my equation. I can write it as y equals 0.001 x plus b. What I need to do is I need to compute the value of b, the y-intercept. A real quick, easy way to compute the value of b is to take either of the points that I have. Okay, it doesn't matter which of them I pick. I'm just going to pick this one because it's closer and substitute it into that equation. When I substitute it in, I have a y value of 4.41 equals 0.001 times the x value of 4090 plus b. Okay, so at this point, all I need to do is take the 4.41 and subtract from it 0.001 times 4090. Okay, and when I do the 4.41 minus 0.001 times 4090, it gives me a resulting value of b equal to 0.32. And you know what? At this point, we're basically done. You may say, done? I don't see it. Don't see it just yet. Well, that's fine. Let's come back to our equation here that we started with. So we know we're going to have y equals 0.001x plus our b value, 0.32. This equation that we have determined here will allow us to compute, okay, the toll for a vehicle of any weight x and the y value that would result being the toll due for that car. Let's take a look at a second problem. Okay, probably going to need to move this one down a little bit. Need a little more space for our second problem, so we'll just kind of move this out of the way here. There we go. So let's take a look at what's going on with problem number 2. Okay, we've got a company, Fun Flyers Golf Discs, incurs fixed costs of $450,000 to set up a new plant. Fixed costs is an important concept in business. It is, as the name implies, costs that are fixed. You can't do anything about it. If you're going to buy a piece of equipment, it's going to cost what it's going to cost. When you use electric, it's going to cost what they charge you. When you set up a plant somewhere, the tax on the property is going to be what the government chooses to tax you. These things are fixed and you can't do anything about them. Okay, so what we have here over to the right, I'm going to make a note. We have fixed costs of $450,000. The problem then goes on to say the cost to make each disc is $1.45. Okay, I'm going to stop with just that part. The cost per item is what is referred to as the variable cost. The variable cost per item is $1.45. This part of the cost varies. It varies depending on how many did you make. Okay. The marketing department projects first year sales of 375,000 discs and a selling price of $6.95 per disc. Okay, so we're going to have a sell price of $6.95. Guess I'll put dollar signs on each of these previous ones so I have my units. And we're going to sell, we're anticipating on selling 375,000 units or discs. All right, let's take a look at what we're asked to do here. In this particular problem, you are presented a series of steps. Realistically, in the real world, all they're going to ask you, what's the profit equation? How many do we need to sell to break even? And you're going to need to be aware of each of these 5 steps and be able to work through these 5 steps to come up with what the company is really after. How many do we need to sell to break even? What does the profit equation look like? Okay, so let's take a look at first the total cost function. What we're going to look at is part A. The total cost, abbreviated as TC, is going to be your fixed costs plus your variable cost. We need to identify what we're going to let X equal in this case. X is the thing that we can change. And the thing that we can change here is the number of discs that we make. So X is going to be the number of discs. Okay. When we go about the process of computing the total cost, I'm going to put down the total cost dependent on the variable X is going to be what costs $1.45 times how many discs did we make, plus it's going to cost us $450,000 whether we're open or closed, manufacturing, or all sitting around watching Roadrunner cartoons. Okay, so our total cost for this is going to be 1.45x plus 450,000. Part B asks you to compute the revenue. Well, the revenue is the money that comes in. The way I typically describe it is, imagine you've got a little company and everything is cash only. The amount of cash in the cash register at the end of the day is your revenue. Now, from the revenue, you've got to be able to pay the electric, the water, the insurance, the lease, the employees, the price of the products, et cetera, et cetera, et cetera. So out of that revenue, you don't get to keep everything. In fact, a whole lot of it's going to disappear on you. But what's left after you pay all your bills is profit. That's different from revenue. Revenue is the amount that you actually bring in. Well, the amount that we're going to bring in is the price we're charging per unit, $6.95, times how many of them did we sell. Okay. Part C says compute a profit equation. Profit, and I hope you all know this, is revenue minus cost. Okay, if you're going into business and you don't know what profit is, you may have chosen the wrong career, or it's time to learn it now, one of the two. Revenue is the total money minus pay your bills. Whatever's left over after you pay your bills is the company's profit. Okay, so to compute the profit, P of X, we're going to take our revenue function, which is a 6.95x, and from that we're going to subtract the 1.45x. Now I'm intentionally making a mistake here because I want to draw to your attention it's a common mistake. We want to do the revenue minus the cost. If I write it as it is provided there, this is wrong because we have not subtracted all of the cost. To subtract all of the cost, your cost function must be in parentheses. This will then give us the 6.95x minus 1.45x minus 450,000. Combining like terms, the x values, we're going to wind up with our profit function is going to look like 5.5x minus 450,000. Now, for people looking in from the outside, they may say, that's absolutely ridiculous. It only cost you $1.45 to make that, and you're selling it for $6.95. That's just absurd. But remember, out of that $6.95, not only do you have to pay for the plastic and the labor to make the disc, but you got to pay for the equipment that it takes, the building that it takes, the insurance, the electric, the water, the taxes, everything else. So when you look at the actual production price of something, without the fixed costs involved, there can seemingly be a big gap in the cost of the item and the selling price of the item. Okay. All right. Part D asks you to determine the profit or loss at 25,000 discs. So what this means is we're going to compute the profit when we make 25,000 of these. This is going to then require the use of our profit equation of 5.5. The x value is 25,000 minus the fixed costs of $450,000. All right, so when we take the 5.5 times the 25,000 and subtract 450,000, we wind up at a negative $312,500. What does this mean? What this says is, if you manufacture and sell 25,000 of these discs, you're going to lose $312,500. That's not a good thing. This brings us on to part E. How many discs must be sold to break even? First thing you need to be aware of is, what does break even mean? break even is the number of units sold to just pay all of your costs. So if you're starting a small business, it's not uncommon for several years, even as much as 4 or 5 years, you as the owner of the business to be losing money. So you put in your 70 or 80 hour week ish. You're going to be working 70 or 80 hours if you're starting a small business. And when you go home, you don't even have enough money to buy a hamburger at McDonald's because you've lost hundreds or thousands of dollars that day. It takes a small business years to build up sufficient clientele and reputation to actually start turning a profit. Okay. I've mentioned that we raise Black Angus, and it took us probably a good 6 years before we even broke even. The first 5 or 6 years, we were losing money the whole way. And we finally gotten to the point where we have the equipment and the equipment paid for, and the clientele, people who want to buy from us, and things lined up and worked out so that we actually make a couple of thousand a year. I'm not making any huge money. Basically, we're just in it because I enjoy raising cattle and we enjoy having good meat on the table. Okay, so break even point. The break even point means the profit is zero. So what we want to do is we want to determine how many discs do we have to sell so that the profit is $0. Remember, at the break-even point, you as the owner of the company still are not making 1 penny for yourself. You're paying your employees, you're paying your bills, and after you pay all the bills and your employees, there's not 1 penny left for you as the owner of the company. Seems kind of harsh, but that's the way businesses start. Okay, to figure out the break-even point, I'm going to take my profit equation, and remember the profit equation is this equation up here. And what I'm going to do is I'm going to set that equation 5.5x minus 450,000 equals 0, and I'm going to solve for x here. So what I'm going to do is I'm going to have my 5.5x equals 450,000. Divide the 450,000 by 5.5 equals, and we're going to wind up with 81,818.18. This brings me to a very important point, not only for this problem, but throughout this course and the rest of your professional career. X is the number of discs that you need to sell. You cannot sell 0.18 of a disc. Okay. When we get into maximizing and minimizing stuff and you find that you need to make 47.362 refrigerators, okay, you can't sell 0.362 of a refrigerator. You do not automatically just round up or down. You need to think about the actual situation. In this case, if we make 81,818 discs, we're coming up a little bit short, which means we're still losing money. In order to break even, and actually we're going to show a slight profit, but the objective here is to no longer be losing money, we need to be looking at 819 discs. Notice I did not round down because of the 0.18, but I considered the context of the problem and said if I round down, I'm still losing money. The objective of break even is to stop losing money. Okay, so that's the reasoning to work through that. Now, there is a last part on several of these problems that you're asked to look at, and that is graph it. Okay, so I am going to come back now, and what we're asked to do here is to graph the total cost function, the revenue function, and the profit function and look for the relationship between those. Okay, so we've got some pretty big numbers here that we're going to be working with. And I'm going to get rid of this and use a different. There we go. We'll go with something like that. Now, the catch here is this graph is not going to be really great because our numbers are pretty big. 450,000, that's a pretty big number. Let's go up. Let's say here's 200,000. Here is 400,000. And the same thing in the negative direction, a negative 200,000, a negative 400,000. And I'm going to have to kind of guesstimate these. Okay. In the x direction, let's say here's 100,000, here's 200,000. And remember, in this direction, this is the number of disks. And in the y direction, this is in terms of dollars. Okay, so let's take a shot at trying to graph these. First thing we're going to do is we're going to graph the total cost. The total cost is a linear function. The slope is about 1.5, and the y-intercept is at about 450,000. So 450,000 would be right about where that red dot is. The slope is going to be a little bit steeper than 1, so we'll do something like this and label this as total cost. So there's that. The next thing I'm going to graph is the revenue function. Now the revenue function is right here. It's part B. It has a y-intercept of 0. It's 6.95x plus 0. Okay, but notice here that the slope is much steeper than the 1.45 of the total cost function. So this is going to go, let's say it goes something like that. And it may even actually be a little bit steeper than that. Say it goes something like that. Here's your revenue function. Notice there is a point where revenue and costs intersect. At the point where they intersect, if you come down, you will see a location on the x-axis. This location where the two intersect is this break-even point. So there are a couple ways to determine the break-even point. One is to set the profit equation equal to 0. And the second is to graph your total cost and your revenue function and determine where those two are equal. Now, when you get into your business classes, they'll make comments like the break-even occurs where revenue equals cost. Where revenue equals cost is where these two lines intersect. So it's completely in line, what we're doing here, with what you'll be told in your business classes. When we then plot the profit equation, and the profit equation is this one that's circled right here in part C, what's going to wind up happening here is our equation, let's see here, let's go green for profit. Our equation is going to intersect at a negative 450,000, so I'm putting that way down here. And we have a slope of about 5.5, which is going to be steeper than total cost, not as steep as revenue. And what it's going to wind up doing is something like this. This is your profit function. And the thing to notice is the profit function intersects the x-axis, which is where y is 0, at the break-even point. Okay, this location is where the profit has a value of 0. Okay, so some explanation of a variety of terms along with the solution to this problem, all in one big gulp. Let's take a look at a third problem. This third problem is pretty similar to which you are presented as the last problem in your homework. You're told that Sam, the owner of Sam's Snow Removal, spends $850 for snow removal equipment. For each job, he incurs a cost of about $7.50 for salt, as well as wear and tear on his equipment. Okay. Compute the total cost equation for snow removal. There are, as with the previous problem, fixed costs and variable cost. We need to identify our fixed cost. Our fixed cost in this case is the equipment, the $850 he spent. The variable cost is going to be the cost of materials each time you do a job. And each job costs him about $7.50 for salt, and he's wearing out his equipment every time he shovels the driveway. Okay, so the total cost is going to be equal to, and I intentionally saved some space there, the fixed cost plus the variable cost. We need to determine a variable, x, typically, and we need to figure out what does x mean. It's kind of funny. A lot of times I'll run into folks who have solved a problem and they get x equals da da da, and I'll say, well, what is x? No, I don't know. It's 7.3, and I say, okay, but 7.3 what? Before you start setting up the problem, be sure you define what x is. X is the thing that can change in this case and will affect the amount of salt and wear and tear that he incurs. Well, X is going to then be the number of driveways that he shovels. Okay, the number of jobs. So X is going to be the number of driveways that need to be done. Okay, our total cost is going to be dependent on X. So I'm putting the X in right there. And we're going to have our fixed cost plus our variable cost. Well, our fixed cost is 850, and our variable cost is 750 times how many driveways does he do? Okay, so what we have now is our total cost equation right there. Part B, okay, maybe Sam's friend or somebody cranks this out for him quick like and says, hey, you know your profit function is going to be 42.5x minus 850. Okay, X represents the number of driveways cleared. We already figured that out. Determine the revenue function and the amount that he charges for each driveway. We have a cost function, we have a profit function, and what we need to do now is to determine the revenue. Well, recall that profit is equal to revenue minus cost. Okay. From this, we can solve for revenue, which means revenue is going to be equal to the profit plus the cost function. Interesting. So what we're going to wind up with here is we have a way to compute the revenue function based on the profit and the cost function. Our revenue function is going to be our profit, which is 42.5x minus 850. Then we're going to add in our cost function. We can put it in parentheses. It's not going to be a big problem here because we're not subtracting, but it's a good practice to get into. Now, let's start combining like terms here. And what we'll have is this minus 850 plus 850 cancels, and we have then the 42.5x plus the 7.5x, which gives us 50x. Our revenue function is going to be 50x. Revenue, if you will recall, the basic definition of revenue is going to be the selling price times the number sold. Also a useful definition for you to keep in mind as you're moving into a business environment. Okay, the number sold is X. That's the number of driveways he's going to shovel. The selling price must be 50. So what we've done here is we've worked out two different parts. It says, or asks us, determine the revenue function and the amount charged per driveway. Our revenue function, we're doing part B. Our revenue function is going to be 50x, and Sam charges $50 per driveway. We have one last thing to compute here, and this is really important. Part C. How many driveways must Sam clear before he begins to make a profit? So Sam's going to be out there shoveling and shoveling and shoveling and shoveling. And for a good chunk of time, he's just going to be shoveling to pay bills. And the question is, when does he hit his break-even point, essentially? Okay, that means all the bills are paid. Well, in order to do the break-even function, we want to compute where does our profit, okay, go write it like this, where does our profit function equal 0? Okay, so let's go back up here at the top of the screen. Our profit function is in the upper left. It says 42.5x minus 850. And if we're interested in the break-even point, we're going to set this equal to 0. All right, with that set equal to 0, this gives us 4250 equals 850. Aha, you know what to do here very likely. We're going to take the 850, divide it by the 42.5, and lo and behold, in this case, we actually get an integer answer. We don't need to be concerned about what do we do with the decimal part. So what this says is Sam must shovel 20 driveways before he can break even. I guess I better put this in a color that you can actually see. So the first 20 driveways that Sam shovels, he's just paying bills. It's the 21st driveway where he's actually making some money. Okay, and this is the way business works. There's a lot of time and effort put into just getting bills paid and getting to the point where you can actually start earning a living, or earning something, even if it isn't a living. I hope these three have been useful to you. Take care and have a good day.